Hi, everybody. This is Mrs. Chargaloff. Sorry I can't be with you today, but what I'm going to do or attempt to do is to go over with you um, the first part of this lab so that way it'll set you up for success in a bit when you go and do the student activity part of this lab. Okay, so by now you should have on your desk a copy of this lab. Um, and if you look at the very top, you'll see that it says in this demonstration and lab activity, you'll strive to answer the following questions. So there's actually two questions that are going to be addressed in this lab. One is via a demo, and I'll show you that on the screen. And the second part is going to be you conducting the activity yourself in your lab group. So with the demo, we're looking at how does temperature affect the density of water? And with student activity, instead of using water temperature differences, you are going to be looking at changing the salinity of the water. So either using water straight from the tap versus adding some salt to the water and seeing what that does to the density. Before we actually get into that, though, I wanted to make some points with you, going over some stuff with our CERs. So, a really big critical component of our CER is actually the R part, which is reasoning. And so, going into your agenda, let me just show you real quick here. I have a slide that's embedded in your agenda that shows you the different parts of the CER writing process, which is helping basically you to create a well-written argument to answer a scientific question. So here we have the different components of the CER. So claim, evidence, and reasoning. You guys are really good at stating a claim, remembering that's a one sentence answer to a question. Two, evidence, which can be either from literature, in the case of your chocolate CER that you had to do, whether you were explaining, deciding that chocolate was a junk food, a luxury item, or a health food. Your factual information or evidence can come from a piece of literature, or in our case, it can come from lab results and observations. The last component there is reasoning. And so the reasoning part is where a lot of students falter because they kind of struggle with connecting the evidence to the claim via some sort of scientific principle. So today you're going to be looking at what scientific principle am I going to use in order to help to connect my evidence to my claim and explain why that evidence is so important and crucial to supporting that claim. Also, we are going to be using domain-specific vocabulary. If you're not sure about what that is, if you go to your binder, okay, everybody real quick, flip in your binder. I'll wait. Go to the reference sheet for Unit 1, which should be the first thing you see under the Notes tab. Look at the back of that. See all those words there? You should have almost all of those defined except for two. Yes, we've covered all those words already except for two. So all of those words are examples of domain-specific vocabulary. So it's words that are specific to that particular content area that are going to help us in order to define or further explain what it is we're trying to say. Okay, so going back to our lab and keeping this CER in mind, or the reasoning most especially, going back to our lab, we're looking at you're going to collect data, make a claim, and explain the reason why your evidence support your claim. Okay, so part one with looking at how temperature and density effect are related. Your research question here is stated, how does temperature affect the density of water? So that is what we're trying to answer when we go down here to your claim. Okay, so the claim, which is a one sentence answer, will be answering this question right here. How does temperature affect the density of water? Okay, so in this experiment, we need to figure out a couple of things. Just like with every true experiment, you need your independent variable, which is your IV, your dependent variable, which is the dV, and then some constants that we're going to use in order to keep the same so we can be sure that the results we get are truly attributed to manipulation of that independent variable. So with looking at the demonstration, we're first looking at how does affecting the temperature of water um, basically give rise to differences in density. Okay, so looking at this setup over here, we have two flasks. and they're upside down on top of each other, connected here. Um, the only thing separated this instance right here is going to be this yellow card that you'll have at your desk when you do the experiment. You'll pull that yellow card out and see what happens. Do these two mix together, or do they stay separate? And so that's going to kind of give you some indication as to what's happening with regards to the density. So going back over here, independent variable, that's the thing that you control as the researcher. So in our case right here, temperature would be the independent variable because we are looking at how does temperature affect density. So we're going to be changing the temperature. We have hot water and cold water, and we're going to see what happens as a result of those temperature differences. Okay, so go ahead and write down their temperature for the independent variable. Now for the dependent variable, that's the variable that changes in response to changes in the independent variable. So what is going to be dependent upon the temperature of the water? In our case, yes, it's going to be starts with a D, density. Okay, so density is going to be changing as a result of the temperature changes. Some things that we might want to keep constant in order to make sure that this experiment is truly, the results you see are truly as a result of the temperature differences in the water are, thinking about things like, for example, the size of the flasks, right? We want to make sure that in both instances, the size of flasks are the same. Maybe the amount of water that we use in each instance, and how hot the water is. Making sure that the hot water are both the same temperature, same as for the cold water. Okay, so those are different things that we might want to think about keeping constant to ensure that our results are valid. Okay, so looking here, number 2, it says write a prediction for temperature and density. So now using all of your 15 years of experience, please think a little bit about what effect does temperature have upon the density of water. So what you could do is write a hypothesis in an if-then statement. So you could say something like, if I increase the temperature of the water, then the density of the water will it increase or decrease? So that's an example of a hypothesis that you could write. So go ahead and pause the video for a moment and come up with your hypothesis for what you think temperature will do to the density of the water. Okay, we're back. So what we're going to do is I'm going to show you the demonstration, and in the observations part of this data table, you are just going to purely write what you see. Don't include anything as far as like reasoning is there concerned. So only what you see happening. The word density should not pop up anywhere in these observations boxes. Okay, it's purely what you see happening. So in the first setup, we'll have hot water on top, cold water on the bottom. And then we'll do it again with cold water on the top and hot water on the bottom. Now I put these videos in your Google Classroom. Okay, so number 1 here is hot water on the top and cold water on the bottom. So let's see what happens here. Okay, I don't know if you noticed, but there was absolutely no mixing of the two colors. We went ahead and colored the hot water red with red food coloring so you'd be able to see if any mixing were occurring. So in this case, we did not see any mixing happening. If you want to watch that again, I'll go ahead and push play so you can see that one more time. There was no mixing of the water whatsoever. And so knowing what you know about the density of objects, right, and that would be our scientific principle, if we take, for example, something that's less dense and put it into some water, what happens to that less dense thing? It usually floats on top of the water, right? Say, for example, a cork. We know for a fact that a cork is less dense than water, and so it floats on top of the water. Well, in this case, we see no overall mixing of the two water solute. One is hot water on top, cold water on bottom. So in a sense, then it looks like the hot water rather is floating on top of the cold water without it mixing. So use that to your advantage as far as being able to come up with the reasoning part of your CER. Let's look at experiment number 2. This is cold water on top, hot water on bottom. So there's the cold water. Instead of a plastic sheet, when you do this, you'll have a yellow card. Notice how they're very slowly pulling the card out, aligning the mouth of the flask together. Now, what do you see there? Notice that the hot and the cold are mixing. Why do they mix now and they didn't mix before, right? Start to think about that. But instead of writing, but remember, in your observations, you're going to be writing, what did you see? So let's play this one more time. So with cold on top, hot on bottom, we see that the water is now mixing together. Looks like the cold is going down and the hot is going up. Over time, the two will be evenly mixed, and you'll have one constant temperature solution in those two flasks. Okay, so on your lab sheet, you should have written there observations of what you saw with the hot on top, cold on bottom, cold on top, hot on bottom. Okay, so looking now at your CER, you're going to answer the question. Remember, what was our question? How does temperature affect the density of water? With one sentence here. Your evidence will be purely stated observatory facts from what we noticed from the videos, which was coming from here. And then your reasoning will be some sort of scientific principle stated that is going to help to connect this evidence to this claim. Okay, so I'll just give you a hint really quick, right? Our reasoning there, our scientific principle that we're looking at is that less dense objects float, more dense objects sink. Okay, so that is true, a constant that is true all the time in the world. So that is a scientific principle that you can use to help to justify why this evidence is supporting this claim. Okay. Now, you are now going to do this part of the lab by yourself, except now you're looking at salinity. So it says here, copy the question again. So the question now is not how does temperature affect density? It's now how does salinity affect the density of water? So right here, you're going to copy that onto the back of your sheet here, and that is the question you're going to address with your well-written CER down here. Okay, so in your groups, please come up with the IV, the DV, and the constants. Write your prediction for salinity and density. Please sketch a plan that will include the question using the diagram to the right. So at your lab table, everybody has a bottle of food coloring and a colored pencil that coincides with that color. So that way you can color in the pictures here which ones you colored. Doesn't really matter. You decide whether you want to make the salty water a color or leave it plain. It's really your choice. As far as the salt is concerned, please make sure you utilize maybe 1 or 2 scoops. That should be plenty. And then when you're all done, setting up your solutions, go ahead and you will make your observations. Ms. Lopez will be there in order to help guide you along the way in case that you have any questions about how to set things up appropriately. But yeah, so hopefully everything turns out well and we don't have any broken Erlenmeyer flasks. And when you're all done, please make sure you clean up your lab station. If you notice here on the very front of your paper, there's a part that says cleanup initials. So when you're all done cleaning up, what you'll do is you'll show your lab station to either our substitute teacher or Ms. Lopez, and they will give you a nice little stamp there that will give you the 20th point that this lab is worth. So without the stamp there, the max you can get is 19 out of 20, even though everything was correct. It's that cleanup part that's super critical that we want to make sure that is conducted. Okay, so you'll get a stamp there. That'll be your 20th point that you will receive for this lab. Okay, so when you're all done, you'll take this home. Please finish it over the weekend. You'll turn it in on Monday into the class basket. So I will see you again soon, hopefully, and we will talk to each other later. Bye. Stop.